Hey guys, it's Mr. Riz. We're going to continue P.6 and talk about trig functions. And a lot of the trig functions we're going to talk about are with Pythagorean theorems. So let's get this started. Okay, if I ask you to, without using a calculator, find the arctangent of 3 over 4, it would be near impossible to do. But what we can do, I could ask you to find the sine of the arctangent of 3 over 4. And that's actually a little bit easier to do. Now what we have to remember that tangent and all these sine trig functions have to do with right triangles. So I'm going to draw a right triangle. And we have our angle here. And now we don't know what this angle is, but we know that the tangent is 3 over 4. And sine functions tell us that it's the opposite over adjacent, so I'm going to do opposite over adjacent. I'm going to put 3 here and a 4 here. Now since this is a right triangle, we can use Pythagorean theorem. This is really easy. Probably should know it already. 3 squared plus 4 squared equals c squared. So we get 9 plus 16 equals c squared, 25. So c equals 5. So now that we know all three sides of the right triangle, if I wanted to find the sine of this triangle, sine is opposite over hypotenuse. The answer would be 3 over 5. Cool. We can do another one like that. Okay, so let's do another one. Let's do the cosecant of the arc. Let's do real fun. Secant. Practice our cosecant and secant skills of radical 3. Alright, so we'll start drawing a right triangle. And what we got to know is secant is the opposite of cosine, and so that's hypotenuse over adjacent. So we need a fraction. We're going to make it radical 3 over 1. So hypotenuse is radical 3, the adjacent is 1. And so now we can use b squared and do, okay, 1 squared plus b squared equals radical 3 squared. So we get 1 plus b squared equals 3, b squared equals 2, so b equals radical 2. Okay, now all we need to do is do cosecant, and cosecant is the opposite of the sine. So sine is opposite over hypotenuse, so it's going to be hypotenuse over opposite. So it's radical 3 over radical 2, and we should clean that up. And we get radical 6 over 2 is our answer. Okay, so that's not too bad when we have numerical values. What we can also do is express these values given equations like x's and stuff. So let's do that. Let's do another one. So let's do the tangent of the arc sine of 5x. Yeah, this is a good one. Alright, so draw a right triangle. That was perfect right triangle. Alright, we should probably make this a fraction if it isn't. So we got 5x over 1. So sine is opposite over hypotenuse. So this is our 5x. This is our 1. Now what we want to do, since tangent is opposite over adjacent, we got to express the adjacent. So we'll call this a and go, okay, a squared plus 5x squared equals 1 squared. And we get a squared plus 25x squared equals 1. A squared equals 1 minus 25x squared. Oh, forgot the 5. There we go. Perfect. So that means a equals radical 1 minus 25x squared, and we can't simplify that at all. Alright, and since we got opposite over adjacent, or that over that. We write it out. And it's okay in my class if you just leave the answer as 5x over radical 1 minus 25x squared. If you want to get real fancy, it probably should be 5x radical 1 minus 25x squared all over 1 minus 25x squared, which you can even factor out, but there's that. Alrighty, let's do something a little bit different. Alright, now what we can also do is solve equations. So if I said that the arctangent of radical 2x is equal to the arc sine of radical x, solve for x. Well, if we wanted to get like this x by itself, to get rid of an arctan, we'd have to use just a tan, because tan and arctan cancel each other out. So we are going to tan both sides. We're going to take it to the beach. Alright, so those are going to cancel out, and we just get radical 2x. Now, when we have the tan of the arc sine of x, we're going to have to express that. So we are going to make a right triangle. Alright, we start with sine, and sine is opposite over hypotenuse, so we'll put that over 1. So we get radical x over 1. We got to figure out this side right here. So we'll call that a. A squared plus radical x squared equals 1 squared. So we get a squared plus x equals 1. So a squared equals 1 minus x. So a equals radical 1 minus x. So that's what this side equals. Well, that's not what that side equals. What we're looking for is the tangent. Ooh, this is going to be a fun one. Not sure if I should have done tangent or not. I might have to erase this video part. Alright, so tangent is opposite over adjacent, so we get radical x over radical x minus 1. We can simplify that, but what we're going to have to do is solve. So let's solve by making this over 1, and well, before we do that, if we square the top, both sides, we got to square the top and square the bottom. So we get 2x over 1 equals x over 1 minus x. Cross multiply. And we get, let's see, x equals 2x minus 2x squared. And what we need to do is get everything over on one side, set it equal to 0 because we have a quadratic. So 2x squared minus x equals 0. So now we need a factor. I'm going to erase this triangle over here. Alright, and we're going to get factor out an x, and so we can get x times 2x minus 1 equals 0. So x could equal 0, or x could equal 1/2. Okay, there's plenty of those, but kind of watch those videos. Some of them come out a bit nicer than that. If you have any questions with this, let me know. Good luck on this section.